Why did you gravitate towards security?
Well, I found myself applying for a security job and then sat down to write up a resume and realized I'd kind of been doing security all along, but hadn't had it in my title. There were things that needed to be fixed, and I was pretty good at the adversarial mindset and picking apart where things went wrong. And the first time I broke into a computer, I was 4. So I'd had it down at that point. And I did a lot of cleanups, and I did a lot of handling systems that had been hit by botnets repeatedly, and it just all added up over time.
So this was something that you had been preparing for a while.
Right, without realizing it.
Interesting. How did you break into a computer at 4, just out of curiosity?
My parents had saved up and bought me something called a WizKid, which was in the 80s, this little box for little kids. And my parents weren't very well off, so they were able to buy me the thing, but it came with about 10 cards, which represented games you could play. They couldn't afford any more cards for it. But I realized the cards just had these barcodes that were read by the machine to tell you what games you could play. And I looked at it. There was no way a 13-digit barcode held an entire quiz game or an entire math game in it. So I knew that the games had to already be in the box.
And you did this at 4?
Yeah, I was a very stubborn and bored 4-year-old on a farm. So I figured out how to force the thing into debug mode by opening up the back panel and playing with some jumpers. And at that point, I just started guessing 13-digit numbers to get free games that I hadn't bought the cards for.
And that worked?
Yes.
Nice. Very nice.
It took me a while, but that's how I got more games.
So you were ready for security at a very early age. That's great. That's great. I want to talk to you about the network time protocol project that you're involved with, of fixing it. How did you gravitate toward that, and how did you know that you wanted to fix it?
Well, it all started in February of 2015 when the NTP implementation maintainer, Harlan Sten, came to me and said, "Help, I need a sysadmin." Among NTP's many problems, there was a build box, and the entire build server, the entire build system depended on this one server in Harlan's home continuing to function. But Harlan no longer had the root password for the system, couldn't update it, didn't know what scripts were running on it, and no one in the world could build NTP without the server continuing to function. And so I had gotten a volunteer sysadmin who was close to me, who wanted to help out the project, and I was helping onboard this person because they didn't have quite the experience in jumping into low-level infrastructure projects, and I wanted to make sure it was as successful as possible. And as I was helping them, I was seeing the state of the code and the state of the infrastructure, and I found out exactly how deep the rabbit hole went. And it was just a moment of panic. It's like, the internet's going to fall down if I don't fix this, and finance is going to fall down if I don't fix this, and a lot of crypto and security is going to stop working and be very attackable if I don't fix this. And we're already having major DDoS problems because no one's fixed this. So I figured out a long time ago, if there's an emergency and no one else is fixing it, you're in charge.
Interesting. How did you arrive at that conclusion? I mean, what was it like to be looking at that and grasp exactly what you were encountering?
It was just it was kind of death by 1,000 cuts.
Was it?
We were looking at the server and finding out what a bad state it was in, and then I was wondering, you know, can we just migrate this to something else? So I started looking at the state of the code and the build, and I was seeing things that were not yet C99 compliant in 2015. The status of the code was over 16 years out of date in terms of C coding standards, which means that you can't use modern tools to do static analysis. You can't use modern tools to do build testing. There's no way to even audit the code using modern tools because it was so ancient. And while we still have access to the older tools, that's just a sign of neglect. And the build system was such that we couldn't guarantee reproducible builds across different systems. And this is extremely security sensitive software. And so that scared me, and I started looking a little deeper and looking a little deeper, and I found out that security patches weren't being circulated in a timely manner. And I don't mean there was a few days delay and it was making me nervous. I mean an order of months to years. And in the meantime, security patches were being circulated secretly and then leaked, and the leaked patches were being turned into exploits, which we were seeing in the wild very quickly, when the security patches weren't being seen in the wild for a much longer time span. And that was really dangerous. I think the panic moment for me, as part of my job, I try to keep track of what the bad guys are doing. And I spend some time with script kiddies, both because I like to know what they're up to, but with the young ones, a lot of them come over to the side of good when the good guys actually care what they're up to and give them a little mentorship. And I sat down with one of these groups one day, and they said, "Oh, Susan, what are you working on?" And I said, "Oh, NTP." And they went, "Oh, that's great for reflective DDoS attacks, but what do people install it for?" They didn't know. That was just scary.
I'm sure that must have been a moment, yeah. A related question on this, how can the internet's infrastructure remain up to date and secure, particularly when it's distributed like this?
So the really terrifying thing about infrastructure software in particular is when you pay your ISP bill, that pays for all the cabling that runs to your home or business, that pays for the people that work at the ISP, that pays for their routing equipment and their power and their billing systems and their marketing and all of these wonderful things. It doesn't pay for the software that makes the internet work. That is maintained almost entirely by volunteers. And those volunteers are aging. Most of them are older than my father. And we're not seeing a new cadre of people stepping up and taking over their projects. So what we're seeing is ones and twos of volunteers who are hanging on and either burning out while trying to do this in addition to a full-time job, or are doing it instead of a full-time job, or should be retired or are retired. And it's just not getting the care it needs. And in addition to this, these people aren't always up to date on the latest techniques and security concerns of the day. And the next generation isn't coming up. I recently started a mentoring group called New Guard that takes early and mid-career technologists, and we cross-mentor and then we match them up with the old guard who are maintaining and who built this software to try to help solve that problem. But in the meantime, there's still not enough funding going in this direction, and there's not enough training happening. And it's a really tough thing because there's a certain amount of what I call functional arrogance involved. I don't have a certificate of Susan is good enough to save the internet anywhere. I don't know who hands those out,
sure, but
they never showed up at my doorstep. There's a certain point where you just have to say, I'm going to decide that I'm in charge of this, and it is terrifying because it's hard to feel good enough to take over something that, if it fails, can take out the entire internet. And so new programmers, or even early and mid-career programmers and sysadmins, say, I'm going to go work on this really cool userland application. It feels safer. They don't work on the core of the internet. And so recruiting for that's difficult. Ensuring the future of the internet and this infrastructure software is one part funding. And in my talk later tomorrow, on saving time, I talk about 3 places you can donate to help with that. And then another thing is recruitment and just getting people who are already out there in the programming world to really get interested in systems programming and to be willing to take that leap of functional arrogance and learn to work on this software, because we desperately need more people. And I'm willing to teach. I have an IRC channel set up on Freenode called Pound New Guard. Anyone can show up and get mentorship. But we need more people.
Where should that funding come from?
Everywhere.
Doesn't matter.
I will take Satan's money if he's not going to give it to me with strings that require me to do horrible things.
Sure.
I care about getting the work done, and everyone depends on the internet at this point. It is hugely economically important. It is hugely important to free speech and freedom of expression. It is hugely important to education. I'm running out of things that it is not important to. We're even depending on it for healthcare at this point. So,
I mean, it's a utility.
Yeah, it really
right?
is at this point.
It's a key utility.
And we're having a tragedy of the commons, and my fear is that if the loosely knit cadre of hackers cannot come up with a way to fix this, that we're going to see increased government intervention, and we're already seeing governments around the world balkanizing their internet. And we're going to end up with separate national internets if that happens. What is keeping that from happening is the fact that so much of the fundamental infrastructure is maintained by loose, uncontrolled, largely undirected volunteers. And I want to avoid that balkanization. I want to keep a free and connected internet.
This is switching gears a little bit, but it's related to it in a sense. How do you feel that organizations, whether for-profit, nonprofit, can balance security with the need to move quickly?
So I don't think that those things are necessarily in opposition, except in that very early stage when you're deciding to build infrastructure into your tech teams or not. I don't know how familiar you are with the difference between what we call regular Army and selected units. So when most people think of the Army, they think of infantrymen marching in rows and this big thing that's hard to move around. The fellow who first trained me for search and rescue operations comes from an Army Special Operations background. And one of the things he taught me is that SOCOM is small and moves very quickly compared to regular Army. And they do that because they're far more highly trained, they're far smaller, and they're better equipped. They're logistically agile, and there are things that you want to do en masse. But when you build in security from the ground up and you have good infrastructure, security becomes very quick. For example, when your programming teams have the infrastructure they need to roll out patches easily and quickly, when security has been built into your software architecture instead of something you try to plaster on afterwards, security actually doesn't really hinder you at that point. What hinders you is when you have an insecure product, when you have not enough developer resources, not enough testing infrastructure, not enough infrastructure to roll out patches quickly and safely. That's when security starts to slow you down. When you bake it in from the beginning and when you build this wonderful infrastructure and scaffolding around your software so that you can roll out patches quickly and safely, and your architecture is itself compartmented and fault tolerant and has minimization taken into account, security doesn't slow you down at that point. But before you build, you have to take a breath and say, how am I going to build this in? Or at some point you have to take a breath and say, I'm going to stop doing what I'm doing, and I'm going to come back and refactor what I should have built in from the beginning. And not everyone's willing to do that, and it takes a certain amount of long view rather than short-term planning. And I wish more people did that, because security doesn't have to be this panicked plastering on after the fact.
And that probably isn't as effective anyways, right?
It's not nearly as effective, but it's what usually happens because security is scary and nebulous to most people.
But if you bake it in at the beginning,
right,
it's not going to slow you down later.
Exactly.
Somebody's got to be in there saying that, right?
Exactly.
Right. What do you feel is the single most important security issue we're facing right now? I know that's a big question.
That's a really big question. How meta do you want me to go?
As meta as you feel.
I would say that the single biggest issue we're facing right now is that we are pushing things that make good sound bites over things that are good first principles security. And that is a real problem right now, because whenever you have a situation where not enough people understand the issues, where there's a lot at stake, and there's a lot of money moving around, there is a tendency to try to sound cool and be easy to absorb and make people feel safe instead of getting good work done. And I hate to break it to you, but really good engineering is rarely sexy. Fixing the pipes is rarely sexy. So often the best things to do just don't make good sound bites. And for example, one of the projects that I've really brought with me to try to push right now is called the Information Security Practice Principles. It's something we're developing in my research center, and it is 7 rules that once you have learned and internalized will teach you, you can derive all information security practice from 7 rules. And that sounds like very little, but when you think about it, it dates back to rules of warfare and Sun Tzu and how do you protect things and how do you make things resilient. And I do a lot of working from first principles. I'm the person who gets called in when we don't know what we have yet, or when something's a disaster and we need to triage. Best practice lists come from somewhere, but why do we teach people just to check off best practice lists without questioning them? So if we teach more people to work from first principles, we have more mature discussions. We can actually get our C-suite involved or our leadership involved, because we can talk in concepts that they understand instead of just talking about what firewall rules we need. And additionally, we can make decisions about things that don't have best practice checklists. I'm the fun person who gets the call when we need to secure a research center on top of a volcano. There's no best practice list for a gigantic telescope on top of a volcano.
Right.
So I got to climb a volcano, break into Gemini Observatory, do network pen testing, and tell them, hey, look, this is what we need to do to secure a gigantic telescope on top of a dormant volcano, and here's what you're doing right, and here's the places that you can mature. And it was really fun, but it was also working from first principles. There is no checklist from that. Security has to come from somewhere.
Checklist, yes.
That's a heck of a checklist.
Yes.
And I want more people to be able to do this. We don't have enough people who are able to do this. And that's why I'm working on the principles as a vehicle for teaching that and communicating that, and for getting people out of soundbite mode, because soundbite mode is very dangerous.
So you need that touchstone of the first principles.
Right.
Keep coming back to that. Interesting. Do you feel like creating those first principles and then educating over an extended period of time is the way to resolve this fundamental issue? I mean, is that really the
I
only
didn't
path?
create them. I just figured out how to explain them to people.
Sure.
Okay, they've been around since before computers. This is stuff we pulled from Sun Tzu. This is stuff we pulled from Roman emperors and their military strategy. This is stuff we pulled from cryptography in the Middle Ages. This is not something I created. This is maybe something I discovered and helped with a wonderful team at my research center put together a mental model for. We just explain it. We don't create it. But I think that this, yes, it's the important thing to disseminate so that more people are able to work this way, because we are educating a generation of box checkers or hyper specialists who only work in one little corner and have learned how to take a security widget and apply that security widget to everything. And that's not helpful either. The principles work on the organizational level, on the code level, on the network level, on the I'm building a device level. It's how security works. And that's why we're really excited about it, because it gives us a mental model and a way to have a discussion that everybody can join in on.
Last question for you. What people or projects are you following these days?
A little bit of everything, and I have to say I spend a lot more time on IRC than most other venues, in part because I can easily background it and ignore it when I'm working, and in part because other people are great filters for information for me. If it's getting dropped into channels with people I care about, then I know it's worth reading, and I'm just so busy that that's been fantastic for me. Right now I've been really watching what Mudge has been doing with the ITL. That's interesting, and I'm waiting to see what comes out of it. I've been watching a lot of neat things that have been happening with what Dave Nally calls pony factor, and some of the different attempts to quantify which software is in the most trouble, especially because I've been trying to figure out where my next rescue is going to be. And a lot of little things. I'm obsessing over Rust and if that's going to change how we do systems programming. So lots of little corners and little widgets here and there.
Great. Well, thank you for being with us.
Thank you for having me.